In this video, we're going to look at power and work. So this is kind of a flashback to, kinetic energy, potential energy. All right, but we're going to look at it from an electricity point of view. So we're going to look at work or energy and power in terms of electricity. Now, power and work are still the same thing that they were before. Power is still the rate at which work is done, and work is the transfer of energy. Okay, the symbols are also the same. The symbol for power is still big P, and the units are still watts. The symbol for work is still big W, and the units is still joules. Or anywhere else in the world, joules. Okay? Biggest trick is, remember watts, yes, that's a W, but watt stands for power, and work stands for joules. So P goes with W, and W goes with J. So W and W do not go together. Alright. Now, what you're going to be filling into these two things is this. Okay, electrical energy's relationship to power. So how is the energy produced by a circuit related to power? Power is the rate of energy. Okay, so if you have a 30-watt light bulb, that's the rate at which energy is used in the light bulb, or produced, or consumed. Okay, while work itself, how much work is the light bulb doing, or how much is the amount of energy that the light bulb is giving off or taking in. Okay, so 30-watt light bulb, 60-watt light bulb. 60-watt light bulb is more powerful than a 30-watt light bulb, which is why it's brighter. This is the equation in your reference table for power. It's a long one, but just like the other, this is the equation, yes, for power. But just like the other power and work equations, you're going to pick whichever two fits your bill. Okay, and they're actually all the same equation, just tweaked a little differently. And I wanted to show you how it's tweaked, because it really kind of makes sense and it's a little bit of fun. Okay, so if we're looking at the electrical power with just potential difference and current, so in this box you should probably only put P equals VI, because that is power in terms of potential difference in current. Okay, I just wanted to include the whole thing so you knew what it all looked like together before we move on. For those of you that are not mathematically inclined, we do have another triangle. All right, if I have power and if I have I and V and I want power, I do that. If I want current and I have P and V, I equals P over V. Okay, so just another one, P is at the top. The other one, V was at the top. This one's P's at the top. Alright, so here's an example of a question. Calculate the rate at which energy is supplied. Now you see the word rate, you know you're going to be using power. Rate of energy is power. So we want to calculate the power which is supplied by a 120 volt source if the circuit has a current of 5.5 amperes. So we have V and I. So we look over here. This one has R, this one has R, this one has V and I. So P equals VI. P equals 120 times 5.5. Okay, so 120 times 5.5. Power is 660 watts. Okay, nothing too complicated. Now that whole long equation, P equals VI equals I squared over R, comes from Ohm's law. Because Ohm's law is like the universal electricity law. which is so awesome. Okay, we just take this Ohm's law, rearrange it a little bit, and plug it in. And here's what I mean by that. If we have P equals V times I, okay, and we know that V equals IR, then we say, okay, well, P equals V, which is IR, times I, right? Because V right here, that's V, which means that P equals I squared times R, or I times R. Okay, so power can also equal I squared times R. I kind of love how that happens. It makes me happy. How you can get from one to another using Ohm's law. So here's another example of a question. A 150 ohm resistor carries a current of 2 amperes. Calculate the rate at which heat energy, so any kind of energy, is produced by the resistor. So power equals our question mark. Alright, so we want power, so we're going to use this. We have I and R, but not V. No V, so we can't use those two. So we're going to use P equals I squared times R. So P equals 2 squared times 150. 2 squared is 4, so it's just 4 times 150. So power equals 600 watts. Last part of the power equation is the V squared over R. And that is the one without current. So if we take P equals VI, and we want it without current, so we want to solve for power without current, we would take that current out. Since current equals V squared over R, or V over R, it would be V times V over R. I just took that and plugged it in down there. And that gives us V squared over R. Alright, so power equals V squared over R, if we want it in terms of potential difference in resistance. So in other words, if we don't know current, and we don't want to know current, and we don't care about current, we're going to pick the equation without current in it. V squared over R. Just like when we did VI, VF, ADT with mechanics. We picked the equation that had what we wanted. We're doing that again. So here's the question. A 150 ohm resistor is in a circuit with a 9-volt battery. What is the rate or power at which heat energy is produced? So rate of energy means power. Alright, so we don't have I, we don't want to know I, so I is not a factor. So power equals V squared over R. In other words, it equals 9 squared over 150. So power is 0.54 watts. 0.54 watts. Okay, power is not too bad. Work, well, power is the rate at which work is done. So power is just work divided by time. So work is power times time. Okay? And we know all these different fun things for power, right? We know that power is V times I, which means that work is just V times I times T. Right? Because we said, okay, work is power times time. And power is equal to V times I. So work is equal to V times I times T. Okay, work is also equal to I squared R times T. Okay, power times time. Alright, and power is V squared over R. So work is equal to V squared over R times T. Okay, and we do the same thing with work that we did with power. We pick whatever fits our bill. So if we want to know how much energy, now this is just energy, not rate of energy. Okay, so if we're looking for just energy, we're looking for work. It's produced by a 50-volt battery, a 50-volt source, which generates a current of 5 amperes in 2 minutes. Now we want to get that into seconds, so we multiply by 60, 120 seconds. Okay, so we know work equals P times T. It also equals VI times T. It equals I squared times R times T, and V squared over R times T. So we say, okay, we know V and I and T, no R, so that goes away, that goes away. We don't know power, so that goes away. So work is equal to V times I times T. In other words, work is equal to 50 times 5 times 120. Work is equal to 30,000 joules. Alright, just to make this a little bit easier and, a little less complicated, you can also use this in terms of a VER chart. Only they're called VERP charts. So we just add power onto the end of our VER, and it still works out. So for example, if I have 2 resistors, one of 4, the other of 6, and they're connected in series, keep that in mind, to a 10-volt battery, what is the rate of energy, so the power, expended through each resistor? Alright, so in order to find this, we need to know everything in each of these rows, or at least 2 things in the row. That's the difference about the VER chart, is you need to know 2 things in a row. Okay, now series. What is always the same? The thing that is always the same in series is current. We don't know current, so we can't automatically fill something in. But we can find our equivalent resistance. Okay, or our overall resistance. We're in series, so REQ equals R1 plus R2. So in other words, 4 plus 6, which is 10. So that equals 10. Okay, now quickness, we can easily find current because we know 2 things in a row, and we want to know 1 more. Okay, so V equals IR, 10 equals I times 10. I is equal to 1. Now that's in the fun current row, which means each of these equals 1. Alright, so we're looking for power, and we know I and R. So we're looking for power, and we know I and R. Well, P equals I squared times R. So power in this case equals 1 squared times 4 and 1 squared times 6. So power is 4 and 6. Okay? You could also find total power, which is 10. These 2 added together, or you can go across. So it's 4 and 6 added together, or you can go across and find it that way. Both work out. Alright. That's it for the video. Good luck on your homework.